Okay, this is example 4 from the Similarity workbooklet. In part A of this question, you have to prove that triangle SVW is similar to triangle UTS. And hence you have to prove that SV is parallel to TU. So in part A, first of all, we start off with the triangles that we're talking about. So we say in triangle SVW and triangle UTS. Now we can see that these two triangles are touching along this side SW. So we can draw them separately, or what I'm going to do, I'm just going to put a little highlighted blue triangle in the bottom triangle there so that you can see that this triangle STU, you can see it a little bit more clearly. The reason I'm not going to draw it separately for this one is that later we have to prove that SV is parallel to TU. All right, so first let's just start with any angles that we can see. Now we can see that in these two triangles that angle SVW is equal to angle STU because they are both equal to 90 degrees. They're both right angles and that's given. So I've just put it up there. That angle SVW equals angle STU equals 90 degrees given that they are right angles. Okay, then we notice that we do have a number of lengths on these triangles. Now we know that definitely the hypotenuse of each triangle would be matching sides. So in the smaller triangle, the hypotenuse is SW, and in the larger triangle, the hypotenuse is SU. So we can see that we've got the side length for SW, it's 16, and the side length for SU is 16 plus 4, which is 20. Hence we can say SW over SU equals 16 over 20. And then we can simplify that ratio by dividing the numerator and the denominator by 4, and we get 4 over 5. And we can write given because we were given the side lengths. Now we need to look for another matching pair of sides in these two triangles. And we do have the side lengths 12 and 15. So we'll go with those two sides. So remember, we're going from the smaller triangle to the bigger one because we've got the smaller number here. SW here was smaller and SU was the longer length. So we can use these sides SV and TU to do our second ratio. So we can say SV in the small triangle over TU in the larger triangle equals 12 over 15. You can divide those both by 3 to get 4 over 5. Now we can see that those two ratios are equal. Hence, we've chosen those sides quite well. So those two ratios are equal. Hence, this is enough for the proof. So we can say, therefore, triangle SVW is similar to triangle UTS. Reason the hypotenuse and the second side of each right-angled triangle are in proportion. The second part of the question, we have to prove that ST is parallel to TU. Now we know that the only way to prove that lines are parallel is to prove that alternate angles are equal, or that co-interior angles are supplementary, or that corresponding angles are equal. Now let's just see what we can find here. We can see that we've got an alternate angle here. Okay, now that we know that those two triangles are similar, we really should mark in the matching angles. Now, because we know that 16 is the hypotenuse and we know this other side 12, I've put a dot here in this smaller triangle. And the matching dot would go between the hypotenuse and this other matching side 15. So I've got a dot down here in this larger triangle. So we can say that angle V, so this angle here at S, so angle VSU is equal to angle TUS because they are matching angles in similar triangles. Now we can only say that because we've just proven that the two triangles are similar. We can also talk about the positions of angle VSU and angle TUS. So, but we know that angle VSU and angle TUS happen to be alternate to each other. So we can write that there, that angle VSU and angle TUS are alternate. Therefore, we can say that SV is parallel to TU because those alternate angles are equal. And that's the end of that example.